Oh, hi, this is Isae, your math, history, and science reporter, bringing you
the TNB Minute. Age. How old is the Earth? Is it young, thousands? Or is it old, millions? Or is it really old, billions? Today, let's look at canyons. How long does it take to make a canyon? Many times, when you visit parks, you'll see signs like this one indicating that slow geological change is what happened here. This is called uniformitarianism. It's naturalism, basically saying what we see now is the way it's always been, slow change. Mount St. Helens erupted on May 18, 1980, showing us that things can happen in a hurry. 2 years later, the hot lava melted a large snowpack that had formed inside the crater and caused a mudflow. That mudflow formed 100-foot deep canyons through solid rock in 9 hours. These canyons look identical to the Grand Canyon, but are 40 times smaller. Could mudflows have happened in other places, and would there be clues left behind? Let's take a look. This is a picture of the canyon at Breaks Interstate Park on the border between Kentucky and Virginia. This is a map that shows how the Russell Fork River flows through this canyon. The circle indicates the view shown in the picture at the right. So you're looking from this tower's view, looking out this way over the canyon, and the Russell Fork River flows this way through the canyon. This is a view from the same location, turned to the left, looking toward the Lover's Leap Overlook. Here's the Lover's Leap Overlook here, and here's Route 80. At this point is where the canyon makes a drastic turn. It had just made a right-hand turn, and now is beginning to make a hairpin turn around the middle, which is called the Towers. That's a very sharp turn. And then when you look at the circle down to the right, that's actually the landing or the platform where you overlook Lover's Leap, and it's 600 feet above the canyon floor here. That's pretty far, and this ridge up here is probably another 50 feet above that. This ridge is what we're concerned with today. This is a hillside that was cut away for the Forest Service, and this is a hillside that was cut away behind this hill for the main road, Route 80, that goes through the forest. The following pictures are from this hillside and from the hillside behind. These layers are not sedimentary, they're vertical. This is a 10-year-old boy standing next to the cliff, and look at all those layers, anywhere from ½ an inch to 3/4 of an inch to an inch thick. Walking along the path, you can see stones that have been inlaid into the wall with layers of clay that are peeling away in a circular curvature fashion. Here's a close-up of those same layers. You can count many layers. I counted more than 35 on several of these stones. Between the large stones, you can see where they've been smashed together like two snowballs, and the line in between them is very thin, as if there's been a lot of force applied, and then something's come through, shaved the top off, and laid new layers on top. Again, I counted at least 35 layers on this stone, and they're eroding away now in this interesting fashion. Here's one that's about the size of a smart car. It had fallen out of the hillside. Look at the curvature layers around the stone. These layers of clay are almost the consistency of dried pottery that's not been baked. Here's another view of that same rock that's about the size of a smart car. You can see the dark inner core here on this side. This rock's obviously been rolling, but what kind of force would push a rock the size of a smart car? Here's a close-up of those curved layers. This is not sedimentary. Here's some of those stones that have been laid into the wall, and they're side by side. These are huge. And again, you can see the black core rock is now sticking out, and that's all that's left on the bottom portion here. Here's a close-up of the same two rocks. Another close-up of the same rock, a dark inner core with up to 40 layers around the outside. Also, here and across the road, there are several smaller wrecking ball-like rocks that could be found in the hillside and ones that have fallen out. These are also made up of layers on the inside, anywhere from 3/4 inch to an inch thick. Here's one that's still in the coal bed across the road. Here's one that's the size, about twice the size of a Suburban. Here's that same rock, and you can see, or that same stone, you can see the cavity left behind, and I counted about 40 layers that are still in the hillside, not counting the layers that are on the rock. Here's some of the layers that came out with the rock. Those layers are quite thick. They look maybe 1.5 inches thick. What kind of force would push a stone twice the size of a Suburban down a valley? Well, these layers were obviously not formed by a vast inland sea, as the sign says, nor were they pushed upward, forming parallel ridges. It's more likely that massive successive mudflows pushed these huge boulders. These are canyon-carving boulders. These boulders came rolling down this canyon at some point in the past, cutting this canyon. Wow, am I glad I wasn't around when those marbles were coming down. It's more likely that the reason they're still here is because they couldn't make the hairpin turn. They flowed down the valley and went whoomp right into the hillside right there. This sign is just one example of incorrect assumptions about slow, gradual geological change. This means that the Earth is more likely not really billions of years old, and is more likely not even tens of millions of years old. This means that the Earth and canyons that are on the Earth are more likely at the age the Bible says, much less than 10,000.
And that's today's lesson in science.
Thank you, and remember, you matter.